A vessel steers a bearing of 50 degrees at 5 knots. At the starting point A here, the angle of elevation of the top of the tower is 10 degrees. So this angle down here is 10 degrees. And the bearing of the tower is 015 degree. 10 minutes later, when the vessel arrives at point B, so this is point B here, the bearing of tower becomes 250 degree. So we want to find the distance from the starting point to the tower and the height of the tower. Let me simply call this tower CD. So we are looking for the length of AC as well as CD. In order for us to find the length of AC, it is important to draw the top view of the triangle ABC. So then we can use the information that we can obtain in triangle ABC to calculate the length of AC. So let's draw the top view of triangle ABC first. My point A is over here, and this is the north direction at point A. So the tower is 15 degrees of bearing from point A. So that means this line down here is 15 degrees, and assuming this is the bottom of my tower, point C. And the vessel itself is steering a bearing of 50 degrees to point B. So this is my AB here, assuming that this is my point B. And this angle is 50 degrees. The question then mentions the bearing of the tower from point B is 250 degrees of bearing. So this is the north direction up point B. That means to say, if I were to connect point B and point C together, and this angle down here will be 250 degrees. Quite clearly, the next step for us to do is to determine all the angles in the triangle ABC. I believe that the easiest one to determine first is angle A, because angle A is simply 50 minus 15, so that will give you 35 degrees here. Next, can you determine angle B? Again, for us to determine angle B, we need to make use of the property of parallel lines. If this angle is 50 degrees here, who is the alternate angle of this angle? As you can see here, this is the north direction up point A, and this is the north direction up point B. If this angle is 50 degrees, so that means to say this angle down here is also 50 because they are alternate angles. Then my angle B will be easy to find. So that goes this way. I have 250 degrees minus of 180 and minus of this orange angle 50. So as a result, you get 20 degrees. Then it will be easy for you to determine angle C. My angle C here will be simply 180 minus angle A, that is 35, minus angle B, that's 20. So this will give you 125 degrees. This is how we can draw the top view of this triangle ABC with all the angles determined. So we need to answer our first question now. Can we find the distance AC here? Let me just highlight in red. So now for this triangle ABC, we know all the angles. We also know the distance from A to B. The length AB is also known because the question tells you the vessel is steering at 5 knots for 10 minutes. So you can use the time and speed to determine the distance AB. So this AB here will be equal to 5 knots means 5 nautical mile per hour. So we need to convert these minutes to hour first. So that will be easily 10 over 60. So that is the distance in nautical mile. And since the question asks us the distance in meter, so why not we just convert everything in terms of meter first. So the conversion rate this year, 1 nautical mile is 1,852 meter. So you need to multiply by another 1852. So you can press a calculator. So the distance AB in meter will be equals to 1543.33 meters. So in the triangle ABC, it will be easy for us to determine the length AC using the sine rule. So the sine rule goes this way: AC over the sine of the angle opposite to AC, so that would be the angle B. So that's sine 20 degrees. So that will be equal to, since I know the AB already, I'll just use the length of AB over sine of the angle opposite to AB, so sine 125 degrees. Make AC the subject of this equation, so AC will be equal to sine 20 times AB over sine 125 degrees. We'll then plug in the value for AB, so that's 1543.33. Press a calculator, you can get AC to be 644.39 meters. Answer. You can also leave your answer in 3SF, so the answer will be 644 meters. Next, we need to calculate the height of the tower, so that is the length of CD in the diagram. Quite obviously, we need to use the triangle ACD to determine the length of CD. So why not we draw the triangle ACD first. This is AC, and the length of AC is determined in the first part. So I'll just use the more accurate data, 644.39 meters. And this is my tower CD. And the good news is that this is a right angle, 90 degrees. So we form a triangle ACD over here. The question also tells you at the starting point A, the angle of elevation of the top of the tower is 10 degrees. So that will be 10 degrees here. So our target is to determine this CD. I'll highlight in yellow. In this question, do you think you need to use the sine rule or cosine rule? Not necessary, because this triangle ACD is a right angle triangle already. So we can simply use Stochastic to solve for CD. You want to determine the opposite side of this 10 degrees, and you also know the adjacent side of this 10 degrees AC. So quite obviously, you are going to use tangent. 10 degrees, that will be equal to CD divided by AC. So make the CD the subject of this equation. So CD will be equal to AC times tangent 10 degrees. So I can then plug in my value. AC is 644.39. You can then press a calculator. I can get the height of the tower CD to be 113.62 meters. So you can leave your answer in 3SF again. So that will be approximately equal to 114 meter.